Today we are here about computer networking and IP addressing. But before we go to IP addressing, we shall first understand some basic concepts about networking protocols and the OSI model. Now, like I said, before we go to IP addressing, we shall first understand some networking protocols and the OSI model. The OSI model is the Open System for Interconnection, OSI model. Out of the 7 layers of the Open System for Interconnection, we have the first one as application layer, then presentation layer, then session layer, and then after the session layer, we'll go to the transport layer, and from the transport layer, we next the network layer, and from our network layer, we go to the other layer known as the data link layer, and then finally the physical layer. The protocols we need to discuss are from the transport layer to the network layer, to the data link layer, and the physical layer. However, at the point of application, presentation, and session layer, we see the computer operating system and the computer application softwares at this point. But from the first 3 layers, we go to the transport layer, the network layer, the data link layer, and the physical layer. At the transport layer, we have a protocol called TCP, Transmission Control Protocol. And at the network layer, we have the IP, the Internet Protocol. From the network layer, we connect to the data link layer, whose protocol is Network Interface Driver Specification. The Network Interface Driver Specification is enabled on the data link layer, and it works with the MAC address, the media access control. So, the network interface driver specification is the one that enables our media access control, which ideally works with the IP address. Now, lastly, we go to our physical layer, and the protocols at the physical layer include the Ethernet protocol and the fiber distributed data interface. So these two protocols are found at the physical layer, where we also see that at the physical layer is the physical hardware control specifications. Physical hardware control specification. Now, the physical hardware control specification, which is found at the physical layer, is purposed to house the Ethernet protocol and the fiber distributed data interchange protocol. From what we have seen, we have realized that at the network layer is our most interested part in this coverage, which takes us directly to Internet protocol addressing. So, Internet protocol addressing is seen at the network layer. From this foundation, we are going to be able to understand what we mean by the IP address. An IP address is a 32-bit number which is divided into 4 octets, or it is generated out of 4 octets, out of the 32 bits. So from the 32 bits, we generate an IP address by dividing the 32 bits into 88. So at this point, we have 8 bits, and here 8 bits, and here 8 bits, and here 8 bits, which is 1, 2, 3, 4, 5, 6, 7, 8. And here 1, 2, 3, 4, 5, 6, 7, 8. And here 1, 2, 3, 4, 5, 6, 7, 8. And here 1, 2, 3, 4, 5, 6, 7, 8. So these are 8 bits, 8 bits, 8 bits, and 8 bits, which will equate to 32 bits. So it's from this that we are going to be able to generate IP addresses and also understand what we mean by network addresses and hosts. Thank you. So an IP address is a 32-bit number. And this 32-bit number is in 3 classes. Or IP addressing is understood in 3 classes. Class A, Class B, and class C. In class A, we have 4 octets: network, host, host, host. And in class B, we have network, network, host, host. And in class C, we have network, 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 and hosts. So from what we understood, we saw that the 32-bit number is divided into 4 octets, and the first octet contains 8 bits: 1, 2, 3, 4, 5, 6, 7, 8. The second octet, 1, 2, 3, 4, 5, 6, 7, 8. The third one, 1, 2, 3, 4, 5, 6, 7, 8. And the fourth one, 1, 2, 3, 4, 5, 6, 7, 8. Which equals to 8 bits. 8 bits. 8 bits. And 8 bits. This equates to 32 bits. Now, computers understand what we call binary. And for that matter, we are going to do some small computation that can help us recall binary. For example, what is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, 2 to the power 9, and 2 to the power 10. Here we shall say 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7 is 128, 2 to the power 8 is 256, and 2 to the power 9 is 512, and 2 to the power 10 is 1024. Now, from this understanding, we shall also try to understand how a computer understands binary. So we shall have what we call the hexadecimal numbers and then the binary numbers. Hexadecimal number starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then to A, B, C, D, E, F, and etc. But for now, we shall end here. So, if you are to convert 0 into binary, it will be 0, 0, 0, 0. And 1 into binary will be 0, 0, 0, 1. And then 2 into binary will be 0, 0, 1, 0. And then 3 into binary will be 1, 1, 0, 0. and then 4 into binary will be 0, 0, 1, 0. And then 5 into binary will be 1, 0, 1, 0. And then 6 into binary will be 0, 1, 1, 0. And the 7 into binary will be 1, 1, 1, 0. What comes in your mind when you see this? We are understanding that the conversions from hexadecimal to binary is a representation of data in digital, in what a computer understands. On your keyboard, when you press 0, this is what goes in the computer system. When you press 1, this is what happens, and etc. But here, if we compute from 0 to F, we get 16. So, what is 16 divided by 2? 16 divided by 2 will equate to 8. What does that mean? That in the first vertical line, we shall have 8 zeros and 8 ones. What about 8 divided by 2? Is 4. That in the second vertical column, we shall have 4 zeros, 4 ones, 4 zeros, 4 ones. And 4 divided by 2 is 2. That in the third vertical column, we shall have 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones. And 2 divided by 2 will equal to 1. That in the first vertical column, we shall have a single 0 and a single 1, a single 0 and a single 1, a single 0 and a single 1, a single 0 and a single 1. Now, let me complete it. Here, we said it will be 8 zeros and 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. And here we said it will be 4 zeros, 4 ones. So 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. And in the third column, we said we shall have 2 zeros, 2 ones, 2 zeros, 2 ones. So we have 2 zeros, 2 ones, 2 zeros, 2 ones. Then, in the last column, we shall have a single 0 and a single 1. A single 0, a single 1, a single 0, a single 1, a single 0, a single 1. So 0, 1, 0, 1, 0, 1, 0, 1. This is how we convert simply from hexadecimal to binary. However, we can do computations like 16 divided by 2 is 8. Actually 8, remainder 0. 8 divided by 2 is 4, remainder 0. 4 divided by 2 is 2, remainder 0. And 2 divided by 2 is 1, remainder 0. So what is this? This is the binary conversion for 16 equals 1, 0, 0, 0, 0. What about 8? 8 divided by 2 is 4, remainder 0. 4 divided by 2 is 2, remainder 0. And 2 divided by 2 is 1, remainder 0. And this 8 is 1, 0, 0, 0, which is here 1, 0, 0, 0. So we can do either this format or this quicker format, depending on what you feel like. Right. Now, from that brief understanding of what humans understand to what computers do understand, it is now understood that computers understand information in binary format, and that's how computers store data. When you press any key on your keyboard, it is tasked to be converted into its binary representation. So now, let us see how we are going to formulate networks and hosts for different classes. So for now, we shall say class A. So we say class A has 1 octet for networks, and the rest of the octets are provided for hosts. So what does that mean? It means that in class A, the first octet is for network addressing, and the remaining 3 octets are for host addressing, which is what? Networks equals 2 to the power 8 minus 1, which is equal to 2 to the power 7, which is 2 to the power 7 from our binary conversion is 128. That is 2 to the power 7. So, but the IEEE rule declares that in the first class, which is class A, we reserve the first bit on the networks, which is like this: 0, 0, 0, 0, 0, 0, 0, 0, 1. Reserved. So at that point, we have reserved 1 and we are remaining with those. So since we are remaining with those, so what does that mean? That means that class A runs, it has a range, network range, from 1 to 128. However, still there is another rule that from the networks, the first and last networks are not used. So, therefore, from the rule of network reservation, the exact number of networks in class A equals 128 minus 2, which will equal to 126. Alright? This is the exact number of networks. Why? The first network is not used and the last one is also not used. What is it used for? The last network is used to start a new network, that is class B, and the first network is used for broadcasting or testing the network. So let us compute for class A. So now let us derive networks and hosts for class A networking. We said that in class A networking, the first octet is provided for network addressing, and the rest of the octets are provided for host addressing. But basing on the IEEE rule, the Institute for Electrical and Electronics Engineers specified that in class A, we reserve the first bit. Reserved. So since the first bit is reserved, we therefore get 2 to the power 8 minus 1, which makes it 2 to the power 7. Therefore, in class A, the number of networks are 2 to the power 7, which is equals, 2 to the power 7 is 128. These are the number of networks we have in class A. But still, it is a rule to reserve the first and last IP. So, still, we reserve the first and last IP, which is equal to 128 minus 2, which is equal to 126. Therefore, the exact number of IP addresses, brackets, networks in class A are 126. Now, we are going to compute and see how we get 126. Here we start. 1, 2, 3, 4, 5, 6, 7, 8. The first one is reserved. And from there, we indicate our respective values for each. That at this point it is 1, here it is 2, here it is 4, 8, 16, 32, this is 64 and 128 from the powers of 2. So when we start converting, where you see a 1, you replace it with what you see above here. So let us start. So we say, for clarity, let us divide them. Okay, let's start. So here we shall say 0, 0, 0, 0, 0, 0, 0, 0 equals 0. So 1, 0, 0, 0, 0, 0, 0, 0 equals 1. So 0, 1, 0, 0, 0, 0, 0, 0 equals 2. 1, 1, 0, 0, 0, 0, 0, 0 equals, here it is 1 plus 2, 3. So here we have 0, 0, 1, 0, 0, 0, 0, 0. Here it will be 4. The fifth, here it will be 1, 0, 1, 0, 0, 0, 0, 0. Here it will be 5. But because we still have a long process from here to the last one, we shall assume that we have converted. You can add. If it is 1, 1, 1, 1, 1, 1, 1, 1, then add 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you'll get 127. Here, let us compute the second last. It will be 0, 1, 1, 1, 1, 1, 1, 0, and this will be 126. From our computation, we have seen that class A ranges from 1 to 127. All right? Now, let's see class B. Now, let us see class B network addressing. So for us to determine the number of network addresses we have in class B, we can see that in class B, we have 2 octets for network addressing and 2 octets for host addresses. Now, which will give us 2 to the power 16 minus 2. And 2 to the power 16 minus 2 will give us 2 to the power 14. At this point, we have subtracted 2 because it's a reserve made by the Institute of Electrical and Electronics Engineers. So it is indicated that we must reserve 2 bits out of the 16 bits. Here we have 8 bits and 8 bits for network addresses. And this will give us 16 minus 2 will give us 2 to the power 14. And from our understanding, 2 to the power 14 will give us 16,384 network addresses. What about the host addresses? For host addresses, we shall have 2 to the power 16 minus 2, which will give us 65,536 hosts minus 2. And at this point, we shall remain with 65,534 host addresses. Now, let us derive the number of networks we can have in class B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 2 are reserved. Now let us start deriving the networks that can be generated from class B. So we have 1, 0, 0, 0, 0, 0, 0, 0. Now, from our discussion, here we have it as 1, 2, 4, 8, 16, 32, 64, and 128. That is what we do. And 128 is our first IP for class B. This is what we do. We shall have 0, 0, 0, 0, 0, 0, 0, 1, which will give us 128. For clarity, let's do that. And then on the next value, we shall have 1, 0, 0, 0, 0, 0, 0, 1. 128 plus 1 will give us 129, which is there. And then the next one will be 0, 1, 0, 0, 0, 0, 0, 1, which will give us 130, because 128 plus 2 gives us 130. Then let's compute the last, and the rest we shall assume 1, 1, 0, 0, 0, 0, 0, 1 will give us 131. And then we shall now assume the last 3 as 1, 0, 1, 1, 1, 1, 1, 1, which will equal to 191. The second last will be 1, 0, 1, 1, 1, 1, 1, 0 as 190. And the third last shall assume it as 1, 0, 1, 1, 1, 1, 0, 1 as 189. As 189. Now, from our understanding, we have seen that class B starts from 128 to 191. So, what does this mean? From the reservations that we must do, we still don't use the first and the last. Of which at this point, if we happen to use the last, we shall not be able to go to class C. So class C will start as the 192. Therefore here, the network range for class B equals 128 to 191. (128 to 191) is the network range for class B. Now, let us see class C network addresses. In class C network addresses, we have 3 octets used for network addressing and 1 octet used for host addressing. So here we have the first 3 octets used for network addressing, which gives us 2 to the power 24. As a rule, in class C, we subtract 3 bits. So, for class C, 3 bits are not used. So, we shall remain with 2 to the power 21. Here, it will give us 2,097,1052 minus 2, which will give us 2,097,1050 network addresses. Alright? Now, let's go to the hosts. The hosts will be 2 to the power 8 minus 2, which is, what is 2 to the power 8? 2 to the power 8 is 2 to the power 8 is 256 minus 2, which will give you 254 hosts. Alright? Now, let us determine the number of network addresses we can have in class C. So, from the reservation, we have 1, 1. The first one was taken in class A, 128, and the second one is taken in class B, which is 64. And the other one is also reserved, so we shall remain with 0, 0, 0, 0, 0. And that will ideally tell us to have 1, 2, 4, 8, 16, 32. So at this level, we are going to have 0, 0, 0, 0, 0, 0, 1, 1, which will be 192. And then we continue 1, 1, 0, 0, 0, 0, 0, 1 will be 193. And then that will be 1, 1, 0, 0, 0, 0, 1, 0, and then this will give us 194. And then we shall have 1, 1, 0, 0, 0, 0, 1, 1, which will give us 195. So here we shall still assume that we have computed everything, and we shall have 1101111, which will give us 223. Let's try to compute the last one. 0111110 will give us 222. So from our assumption, class C ranges from 192 to 223. That's the network range for class C. Thank you.